Hi everybody, welcome to the last video in statistics hypothesis test for the population mean. So similar to what we have in chapter 9 where we do the confidence interval or the point estimate for the population mean, we use the t distribution. Here we use the t distribution for the population mean as well. So the review of the t distribution, we have that. What we do is the test statistic we calculate as the t distribution. So this from the sample, this from the sample, and so that will be t equal to, right, and that will be the test statistic, right. So when we do the test statistic, when we use that, similar to previous section, we have the classical approach and the p-values approach. Like I said, we only focus on the p-values approach, and we use a calculator to calculate that. Right. So hypothesis testing about the population mean. So here's some fine print that we have to pay attention to. The sample is obtained using the simple random sample method. The sample has no outliers, and the population is normally distributed or the sample size large. So for that we can use the math, the t distribution, and the sample values are independent of each other, right? And then the step will be similar to what we have state the hypothesis. Alpha is given, and compute the test statistic. We won't do that. Just use the classical approach. So we just find the p-values corresponding to that statistic, and after that we'll reject or not reject if it is less than alpha, p less than alpha. So once again, HO is for the status quo. When p is low, then it must go. Right. I said let's jump right into the first example here. Use the t-test to test the claim that the mean is equal to 21.3 given the sample has that information. Right. Now the test statistic to the nearest thousand. Okay. That. Okay. I said we use the p-value, so we're not going to do the test statistic at all. We don't need that. Right. Now, first the hypothesis. The claim it is equal to, so that when it has the equal to, equal, it has to be the null hypothesis. This one doesn't say less than or greater than, so we just say it's not equal to. And that is the two-tail. And then the second step is alpha is 0.01. Step 3 is a computation. Right. For the sample we have n equal to 12, mu 20.8, and s is 2.1. Right. So again, population mean, we have to use the t distribution. Right. So stat or test, and then t-test. T-test. Where was that? Right. Option number 2. Right. We're going to have the statistic because we have that for the sample. Right. First, the hypothesis we have is not equal to, so it's not equal to, we select that, and so mu is not equal to mu naught, so mu sub 0 here, that has to be 21.3. right? So say 21.3, so the hypothesis is mu not equal to 21.3, that alternative hypothesis. Right, now the x bar 20.8. From the sample we have 20.8 and standard deviation of 2.1. N is 12. Assume that all the conditions are satisfied. Now we calculate. Right. And then of course that test statistic and the p-values is 0.427. Right. P-value is bigger than alpha, so we do not reject. And then the conclusion. If it do not reject, there is not enough evidence. To say that it is different than 21.3. To say that the mean is different than 21.3. Right. Now if we use stat range, go to stat, the t-stat, one sample with summary. Right, the sample mean 20.8, standard deviation 2.1, sample size 12, and enter exactly as we see that is not equal to, so compute, and we have the p-values at 0.427. Right, so that's exactly as we have, and p greater than alpha, so do not reject. Right, I said we just focus on the t-values. I mean the p-values approach. Right, here, if we use the calculator, that stat, go to test, and option 2, t-test. Right, that's what we have. Simple enough. Right, next, assume the resting metabolic rate of healthy male in complete silence is that. And then the research do some sample on 45, so n is 45. And we have the mean, standard deviation. So those are the information for the sample. Right, at 0.05 test, is there enough evidence to conclude that it's different than this? So it is different than meaning not equal to. So we first say the hypothesis. H0 and H1. We say that the mean is equal to 5710. Alternate hypothesis not equal to. And not equal to, that is the two-tail. We need that to enter in calculation. That involve heavily in the computation to determine if it is left, right, or two-tail. Number 2 is alpha 0.05. Just keep this in the back pocket. Next, the computation. And what we have is n is 45, and the mean actually this is the mean of the mean is 5708.07. Actually this is from the sample, so I use wrong notation here. For the previous sample too, sorry. This is the mean for the sample, so just X bar. Standard deviation is 992.05. Right, and then we will do the computation. From there we have the p-values. Right. Stat. Go to test. T-test. Statistic. This is not equal to 5710. It's not equal to. Right. Now, the sample information. The mean is 5708.07. Standard deviation 992.05, and that's 9. And then 45. Right, let's check. Okay, glad we check. So we have the mean, standard deviation, and n, that from the sample, and then the hypothesis, mu not equal to that. So that's good. Let's calculate, and we have the p-values is that much. And of course, once again, p-values is bigger than alpha, so we do not reject it. Right, and the conclusion. There is not enough evidence to support that it is different, and to claim that the mean is different than 5710. Right. More exercise. A local retailer claims that the mean waiting time is less than 5 minutes. So the mean is less than 5 minutes. Right, it doesn't have the equal sign, so that will go to the alternative hypothesis. No hypothesis always equal to. Right, a random sample of 20, so there's 20. The mean standard deviation. At 0.01, test claim. This is less than, so that will be the left tail. Right. Number 3, computation. What we have is n equal to 20. The mean for that sample is 3.4, and standard deviation of 2.1. Right, with that we compute the p-values. Stat, go to test, option number 2. Right, let's focus on the hypothesis first. It's less than 5, so less than 5. So we have to here or here, and we choose that. So it is less than mu naught, so mu naught is going to be 5. Right, so get that out of the way. So the alternative hypothesis, the mu less than mu naught, which is 5. The mean 3.4, standard deviation 2.1, n is equal to 20, and we calculate. Right, in this case we have p-values of 0.0, 0.014, and p is less than alpha, so we reject the null hypothesis. Even though we said reject, but is that good or not? Or is that support the claim or not? Let's go to the conclusion. Right. So if it is reject, we always start with there is enough evidence to support H1, and there is enough evidence to support that the mean is less than 5 to support that mean waiting time is less than 5 minutes. So there is enough evidence to support the claim. Right, that's what we have. Right, next, a local group claims that the police issue at least 56 parking tickets a day in their area. To prove their point, they randomly select 2 weeks. So that's like 14 data here. The search yield the number of tickets for each day. So that's for 14 days. At 0.01, test the group claim. Right, so the difference here is we do not have the statistic of that sample. We have the data. So it's fine. From here, if we want to store this into list 1 and then find one variable statistic, or if we just use the t-test and we just use the data in the t-test. Alright, but first, the hypothesis. Right, they said at least 56. So we said the mean at least so this has the equal sign, so we have to write the complement. But doesn't have the equal sign, and we say with that because the null hypothesis is always equal to. Right, next, alpha 0.01. Now the computation. We don't have any summary for the sample. We just have to use data. So first I'm going to enter this into a list, and we either calculate the statistic or we're just going to store that and do the t-test based on the data. Right, edit. Now we enter the values 70, 48, 41, 68, 69, 55, 70, 57, 60, 83, 32, 60, 72, 58. Right, there should be 14 of them. 70, 48, 41, 68, 69, 55, 70, 57, 60, 83, 32, 60, 72, 58. Alright, so that's good. Now we do the t-test the same way, but this time we choose data. Data come from this one, and then we will specify that this is less than 56. So mu less than 56. This come from this one. Yeah. So if we have data, we just use data. If we are given statistic of that sample, use that. Otherwise, if we have data, use the data. So less than 56. Right. Calculate. Right. So that's actually calculate the mean and standard deviation, everything here. So the p-values here is 0.87. P is bigger than alpha, so do not reject the null hypothesis. So I go to the conclusion. Do not reject, so there is not enough evidence to support that claim, to support that less than 56 ticket issued per day. Yeah. So there's not enough evidence to support H1. So that's the language of hypothesis testing. Right. I do want to use the StatGrunch to do this from. Right. First I enter the data 70, 48, 41, 68, 69, 55, 70, 57, 60, 83, 32, 60, 72, 58. Stat, t-stat, one sample with data. Now the data come from the variable 1. Right, what do we test? It's 56, and this is less than 56. Right, compute the p-values. That's what we have. So just like what we have using the calculator. Alright, go to the next problem. According to the U.S. Mint, quarters weight 5.67 grams. A researcher is interested in determining whether the state quarter have weight that is different than that. So it's different. And when we select 18 quarters and weight them, and these are the weight, right? So first, it's different from that. If we write it out, it will be like this. It doesn't have the equal sign, so that will go with H1. Alternative hypothesis. H not H1. Alternative hypothesis, mu not equal to 5.67 grams, and equal to is the null hypothesis. This is the two tail. Right, alpha 0.05, and then the computation. We are not given the statistic of sample. We just have this data, so we have to enter that in the list, and then in the t-test we indicate that we use data. Right. So edit. I'm just going to keep that list. I'm going to go to the second list. Right, 5.7, 5, oops. 5.7, 5.67, 5.73, 5.61, 5.7, 5.67, 5.65, 5.62, 5.73, 5.65, 5.79, 5.73, 5.77, 5.71, 5.70, 5.76, 5.73, 5.72. Right. So we do the computation. We have the data in the list, and we hit stat and go to test and the t-test, and the data is from the list 2, and the mean is different than 5.67. And it's different than, so the mean is equal to 5.6, not equal to 5.67. That alternative hypothesis, and then we calculate. Right, I have the p-values is 0.0135, and p is less than alpha, so we reject the null hypothesis. And then 4 will be the conclusion. It says there is enough evidence to support the claim. So, of course, we write too many of this. I'm just going to write. There's enough evidence to support the claim that it is not equal to 5.67. Right. Again, we have that information, and we use the t-test and come from the second list. It's not equal to 5.67. Right. So we have, just make sure that you have that on list 2. Right. So with that, we finished a statistic. Thank you for watching.